Welcome to our demonstration for the blockchain platform for access tracking system. My name is Mark from I2R. In this video, I will first briefly introduce our project. Then I will talk about the details of our system architecture design with you. After that, let's go deep into the data model design, as well as the user group permissioning mechanism. Last but not the least, I will show you our demonstration with real scenarios by using screen recording. Firstly, let's go to the introduction. Our blockchain is a distributed peer-to-peer ledger system. It is designed to record and manage digital assets in a safer manner. In our system, users' access and contribution to the ledger is regulated by our self-defined user group permissioning mechanism. And our system is able to work within a distributed network. Each mining node is capable to be a client as well as a server simultaneously. Now, let's move to our system architecture design. As I mentioned before, our project is designed to be a distributed application. The source code of our blockchain platform consists of three projects: a client program, a socket server, and an HTTP web server with database, which is implemented by using Django framework. Most of our source code is written in Python programming language in version 2.7. All those projects can be compiled and run on all mainstream operating systems, including the Linux or Mac OS X or even the Windows. This slide shows you the system architecture design from functionality perspective. We categorize the functionality of our blockchain platform into three components: the data management, which is highlighted in blue color; the user interaction component, also known as the client, highlighted in orange color; and the network interaction components, also known as the server, shown in green color. By combining all three components, our platform could perform all key operations of a blockchain, including data browsing, transaction submissions, block mining, or even user profile management. This diagram depicts the network architecture design of our blockchain platform. The project in the distributed network communicates with each other through HTTP and UDP channels. The HTTP channel will bear all peer-to-peer communications, and the UDP channel will handle all message broadcasting. In this diagram, you can have a deeper understanding to the functionality of our three projects and how they collaborate within the network. Next, we come to the data model and user group design. There are two data classes defined in our database, and we will show you more details in the next slides. For the user groups and permissioning mechanism, we define four levels of user permissions. Observer is the lowest level of user in perspective of permissions. An observer can only access the ledger to browse the data and retrieve his or her own profile. The user group above observer is called staff. Staff users are permitted to create and submit a new transaction, request a new block mining, and access of user list. By obtaining public keys of other users, a staff user will be able to participate in digital signature verification once needed. Miner user has additional permission to verify transaction and block mining. A miner user will host a full function server together with a database in the backend. Therefore, a miner user will need to frequently synchronize with other mining nodes within the distributed network. The admin user is a super user in the network with assumption of trust and authority. In our blockchain platform, The admin user will be the router when a user firstly logging in, and handle all the key pair management of all staff users. Please take note that both observer and staff users do not need to host a database. Therefore, there's no need to run backend server on their machines. For the observer and staff users, they only need a client project to use blockchain platform. This diagram shows the entity relationship of our database scheme design. The primary key of a block entity is an integer attribute called height, and each transaction is identified by its ID number assigned by system automatically and incrementally. The relationship between block class and transaction class is a typical one-to-many relationship. Before we end this video, we will show you 3 short demonstrations to simulate typical operations designed for 3 user groups: observers, staffs, and miners. The demonstration is recorded on real machine within real network. The network is set within I2 intranet, and each peer node is identified by their hostname and IPv4 address. Besides the machine we do the demonstration, we also predefined 6 peer nodes to be active and running in the network. Among the 6 nodes, there's 1 admin node, and 5 others are all mining nodes. Next, we will firstly log in as an observer. Then we log out and move forward to the second demonstration. In the second demo, we will log in as a staff user. After that, we will run the server in the backend and log in as a mining node. Here is a summary of our demonstration stories. Let's do it one by one. That's all of our demonstration. If you have any questions, please feel free to contact me or my colleagues. Thanks for watching.